Hello, welcome to Offshore Wind, the Deepwater Frontier, a comparative analysis of fixed bottom versus floating technology in terms of economics, ecology, and engineering viability in the 2026 landscape. We have reached a turning point in 2026. Fixed bottom wind is a mature, reliable technology, but we have run out of shallow water real estate. To meet climate neutrality, we must move to deep water. Deep water means floating technology, which is the problem. It's more expensive and less understood ecologically. However, in research, today we explore five pillars of research to determine if the 20% higher speed winds and the 23 to 1 environmental return of investment justify the engineering complexity and the unique reef effects on the deep sea floor. So, first off, let's start with the LCOE gap and the capacity factors. We are looking at the levelized cost of energy, or the LCOE. Currently, fixed bottom installations are incredibly efficient at $47 per megawatt. However, floating technology is higher, averaging about $80 per megawatt. So why pay more? It's because floating turbines can be massive. We're comparing about 16 megawatts compared to 11 megawatts in fixed turbines in shallow water. And the math justifies this. Because wind is 20% stronger and more consistent in deep water, the capacity factor is significantly higher. According to Castellano and authors, the initial the high initial capex is a hurdle, but the learning rate, in terms of how much cheaper it gets as companies build more, suggests that FOW is the only path to the U.S. West Coast energy needs. So now we talk about the reef effect. When we put these structures in the water, we aren't just generating power, we are also building artificial reefs. These substructures provide a hard surface for mussels and barnacles, which allows to create a localized ecosystem in an otherwise empty part of the open ocean. Then we have to think about the FAD effect, or the fish aggregating devices. Pelagic species like tuna and billfish will naturally congregate here, meaning more will come about. A critical question is, does this actually increase the amount of life in the ocean, or does it just act as a trap that makes fish easier for predators to find? This is a key pillar of my ecological inquiry. Now we got to move on to benthic and pelagic interaction, especially in terms of entanglement and seabed disturbance. And we had to debunk a myth here as well to help prove my point. We often worry about whales getting tangled in mooring lines. In reality, these lines are too thick and stiff for a whale to wrap around, meaning it is safe to build. The real danger, though, is the risk of secondary entanglement. This is abandoned ghost fishing nets getting caught on the mooring lines, creating a deadly trap for marine megafauna. However, there's also a seabed advantage. Unlike fixed bottom turbines that require traumatic pile driving, which causes massive noise pollution, floating anchors, also suction caissons, have a much smaller physical and acoustic footprint. This aligns with Perzaki and authors emphasizing the need for better deep water baseline data. Now we got to look into the engineering and the lifestyle logistics. Fixed bottom turbines are stuck. If a blade breaks, you need a jackup vessel, which costs up to 300,000 a day in 2026. We can disconnect a floating turbine and tow it back to a harbor for repairs using standard tugboats. However, this requires ports with specific depths and specialized quays. Part of the study investigates the operational expenditure of the tow to port model eventually cancels out the high initial capital expenditure, or the capex, of the mooring systems. Now we should focus on policy and hydrodynamic impact. On a massive scale, extracting wind energy can actually change the local ocean mixing, also known as upwelling. We need to research if this affects the nutrients available for phytoplankton. In terms of socioeconomic dynamics, even if the science is sound, public perception is a critical matter. Per Firestone and Kempton, we must address the not in my backyard sentiment by highlighting the creation of green collar jobs. In my final conclusion, floating wind is the inevitable next step. The higher LCOE is the price of admission for access to the strongest winds on Earth. By understanding the mooring line risks and the reef effect benefits, we can engineer a transition that is ecologically responsible as well as economically